So firstly, I would like to talk through what is the problem out there, what is the problem to be solved. And the big part of that problem that in the health monitoring of the bridges is the current system and processes, the inadequacies, and I will talk a bit more on that. As I mentioned, there is some deficiency in the current system and processes. So what would be the ideal system that would solve those problems? I will talk through that, kind of ideal system that will deliver the things that we are talking about the problems that in the first point. Then I will go through a tool, a system that Horsham City Council is using, and it is the first council to use this tool in Australia. And I will go through that, and I will end my presentation with a demonstration, short couple of minute demonstration with you. All right, sorry if anybody else is scared of the photo. It is not a distant thing, you know. Bridges has been a time bomb. It's a ticking time bomb at the moment for a number of reasons. There are 35,000 or so bridges in Australia, and most of them are built in 1950s or earlier. So they are in the 2/3 of their useful lives. So if you count the per bridge 6 million, then you can see how much money is needed to renew that one. But many of the organizations, they have not even planned in their long-term financial plan or so to work around that. Okay, that's the first part. Second part I want to talk about is the bridges. When they're designed, these bridges were designed in 70 years before. The designer may not have in their distance imagination the type of trucks that is taking these days. AB triple, B double, HML loading, and you name it. So this is the current scenario. The bridges were designed for a low limit. Now you have higher load limit. And you may think that, okay, let's close the bridge. I mean, at least lower the limit of the load. I have tried when I was working in operation roles for a number of years, and again current role. But you see the protest in the council chamber. It is not that easy. So as a result, what is happening is that the bridges are taking more loads, more stresses. And if you look to the Australian standard very deeply, you can find there is a clause saying if the bridge has taken a particular load, say B double, safely transited that, then you could basically, Australian standard has a clause that says, okay, the bridge can be considered to be for that load limit, despite your various tier of structural assessment saying this doesn't have a capacity. So this is a real challenge. But replacement of the bridges is unquestionably costly, and per capita bridges in Australia is very, very high. So individuals has a big burden to manage those bridges. So only thing we have to do is that how to manage those health of the bridges. But that hasn't been as good. If you look in individual councils or you may be the state government organization, how much money is assigned for the maintenance of the bridges, it is not much. So as a result, this is the fate. This bridges has been a time bomb. And probably this is a very famous, you may have seen it in the news, but these are not very famous. So they just last year or around 1.5 years before in Victoria, and this is in New South Wales. And this is not an uncommon thing, but it will be more because the bridges are aging and loads is increasing. So how we are managing the health of the bridges at the moment? That I would like to talk through. So we collect the data, like this sort of thing, and then take the photos of the bridges. Somebody do the 6 weeks or even a couple of weeks of courses, and he can do the level 2 assessment of the bridges. He produces the reports like this, and the reports in the PDF they send you the hard drive with the photos of the bridges. This is what the current scenario is. As a result, what is happening is that the information, like okay, the particular bridge has component, there's the condition, and these are the photo references of those issues. But 5 years before, the same data was taken. Similar, but where are they? How they correlate? This level of convenience is not there. As a result, the last data is not there is there, but if you wanted to spend 2 hours to collect those data, nobody would do that. We want it. It is, as a result, if executives ask you how much money is required for the maintenance of your bridges, you don't have good answers in your fingertips. And then this is the reason why health monitoring hasn't been adequately funded. It is not a big cost, but people are spending money on the things which are clear. There is a clarity of the scopes. And because of our current processes, there is the bridge health monitoring hasn't been adequately funded. So there is a need of solution. So that solution I'm talking about is, if it is 10 years before, I would not even dream to have that sort of solution. But now we are talking about it's a digital technology. Everything we got at the moment is a cloud computing, artificial intelligence, and everything is so robust. So I can think of dreaming of something which is bigger than what we used to. So what I think, a system which should be very simple. Let me say I'm talking about the deliverable of a system that will solve those other problems. One is that it should be very simple to use. There should be evolution of the defect. Like there is an issue, there is a defect, a small crack on the girder, and if 5 years before and now the crack is the same size, then it's not the severity is low. But if it is propagating, the severity is higher. But that sort of things is not available in our current system of data collection and things. So something which is simple to use, and it has the ability to share between if there is a spalling or reinforcement, or there is a corrosion, or many types of defects on that bridges, then you can easily collaborate between the asset manager or the solution designer, supplier. That sort of solution is necessary, and it is possible. Because I'm talking about, this is not a photo, it's a digital twin. So this is also not a photo, it is a digital twin. And I'm a civil engineer myself, I do CAD drafting and I can do 3D modeling, but it is not created using the AutoCAD or something like that. But it is lots of photos are taken, and then very easily, quickly you can develop this type of a model. Same as this one. These are a twin, digital twin, so that you have a twin of your structure in your fingertip, and you can communicate to the degree you want to explore the solution about costing, about and that is when the possibility of the collaboration starts. So it's all about the digital twin and collecting the data and using those data. That's a solution is I would call as a proper solution that delivers those problems that I defined earlier, that those problems can be answered. So this one of the solutions that there are various solutions in the market, of course, but this dynamic infrastructure, this is very widely used in the US and in Europe, and I have started using Horsham with a very successful result. So I would like to go through how does it solve that problem. Okay, as I said in the beginning, the deliverable is that it should be simple to use. It should be quite simple. It shouldn't be complicated as, this is the photo of the pier, name it that one, describe how much the extent of that damage is, what is the condition. Not like that. So what we wanted is that just take a photo, then it automatically detects the issues. It identifies what type of is corrosion, spalling, reinforcement or leakage, and all sorts of things. It automatically detects the deteriorating areas, and it identifies even the critical defects. And it suggests the priorities. It gives you opportunity to do the risk evaluation of the risk. And even it can be customized in terms of the alerts, depending on if there is a girder, there is a large crack in the middle of the girder, that is a high risk. If the same size of crack is in the edges of the girder, that is low risk. So those are the things you can alert to the various user group or various stakeholders. This is a very fascinating part, as I mentioned to you earlier. The same defect, if it is not propagating, it is not a risk. because it could be an environmental crack, a minor environmental crack. But if that crack is propagating over time, that becomes a significant liabilities over time. So the system itself identifies the defects over time, how it is evolving. This gives you a kind of feeling that this is a higher risk and lower risk, and it's not only that, it gives you a prompt, or it gives you a severity definition of that particular defect. So in summary, what we do from this system is that you put the photo, upload the photo in the system. It's all cloud computing, cloud-based system. It's not sitting in your council server or show. Analyze the data automatically. It is not human involved. You can change it. You can enforce if the data coming from that one if you think that the result can be swayed a little bit, you can work around that as well. But generally, if you do play chess and you know it, AI is much powerful than human itself in many fronts. So, and then it delivers a dashboard of all those things that you would like to know about that bridges or about that structure, about the severity, which element, how many of them, and then once you have this sort of information, and also it produces a 3D model. As I told you already, you dump the photos, it produces a 3D model, and you can start to integrate about that one, those issues. The summary is that it is a visual medical record of that bridge. It is, if you have the photos collecting from 10 years before and now how that issue is propagating, every information about the bridges can be seen. So basically you can see the defect, and if you click on that defect, it goes to the 3D model, or you click on the 3D model, it goes to the defect, and vice versa. So basically it opens the opportunity to a complete collaboration between all stakeholders. So yeah, this all those bridges you have, you can see the dashboard, and it's a very interactive dashboard. You can click, safety defect or what type of defect it is, and it is all the whole data set is sitting under the individual elements. This is the bottom up. So basically, if there's a crack on the gutter 1, gutter 2, and those elements, all things are collected as a dashboard. Of course, you can download data and then use the Power BI or other tools to present more vividly if you'd like. So this is also very important, I would say, is that interacting with the tool. Suppose, like at the moment, if you have done, there is a cracking, or there is a reinforcement spalling, or things like that. So you fix the issue. How do you report that back? It's quite complicated. You write it down, talk to somebody, and the things. But what you do, take a photo, send that photo to a particular asset ID and that email, then whole dashboard is updated instantly. So you are in control of the entire data sets in a given point in time. It gives you, what it does at the end is that you have how many of the corrosion defects, how many of the spalling defects, and all those issues you can quantify the cost. When you can quantify the cost, then there is opportunity starts to fund those work. Because at the moment, when there is not clarity, then there is no funding available, because there is no clarity. So I would probably spend, this is all I was trying to present. I'm a bridge enthusiast myself, so I find this product used in US and Europe is quite fantastic, and we started using Horsham. I find is using very well, and it can be used into other assets like a dam or water tower, or it can be expanded, I feel, to the further other drainage and the like. So try to think differently, because this is I don't want to be in a smaller council like of the 50,000 catchment. Horsham shouldn't be the first council to use this sort of product, but but that is the reality. That is what's happening. So I would like everybody starting to think differently and go against the current status maintaining the habit. So I'll quickly go through that tool. So is this the, okay, I think that they have to be. Thank you.
Thank you, Krishna. What a fantastic use of AI, particularly for something so specialised as bridge inspections. Does anyone have any questions?